This is Unit 7, Physical Behavior of Matter, Lesson 2, Calculating Heat. How is heat calculated? By the end of this lesson, I can calculate heat, specific heat, mass, and change in temperature of a reaction given three of the four items. I can use my reference tables to determine the correct heat formula to use and find the physical constants for water. Do now. Calculating heat of reactions. Q is the symbol for heat. This is equal to delta H, and it is measured in joules or kilojoules. If Q is positive, the heat is endothermic. If Q is negative, the heat is exothermic. The heat of the reaction is based on the mass of the substance, the temperature change it undergoes, and the specific heat. So what is specific heat? Specific heat is the heat needed to raise the temperature of 1 gram of a substance 1 degree Celsius. That is the definition. So if we look at these different specific heats of these different substances, we should notice something about them. Take a quick look at all of those, and what do you notice? Write down something that you notice. So the specific heat of water is located on table B. So this is where you need to remember to look. You're going to forget to look here for the physical constants for water. This has our heat of fusion, heat of vaporization, and the specific heat capacity of water. So we'll talk about all three of those in this unit. So to calculate heat, we're going to use Q is equal to mc delta T, which is located on table T. Q is equal to the heat, M is equal to the mass, C is equal to the specific heat of the substance, and delta T is the final temperature minus the initial temperature. So here's an example solving for heat using our Q equation. Our Q equals mc delta T. How much heat is needed to raise the temperature of 500 grams of water by 15 degrees Celsius? So some things that you should notice in this question are we have raised the temperature. We have a temperature change. We're going to raise the temperature by 15 degrees Celsius. There are 500 grams of water, which means that's our mass, and we have water, which is our substance. So what we need to do is first list the known variables. M is equal to 500 grams. C is equal to 4.18 joules per grams degrees Celsius from table B. Delta T is 15 degrees Celsius, which we have right from the problem. And Q is going to be our unknown, how much heat. So step 2 is determine the product. So we're going to plug into our formula, Q equals mc delta T. Q is equal to 500 grams times 4.18 joules per grams degrees Celsius times 15 degrees Celsius. And if you look, grams and degrees Celsius are going to cancel out. So if I do the multiplication, Q is equal to 31,500 joules. And if we round to significant figures, we'll have 32,000 joules. Example, solving for a specific heat. Sometimes we'll have a different substance besides water, and we'll need to find the specific heat. So what will happen is the temperature of 95.4 grams of copper is increasing from 25 to 48 degrees Celsius and absorbed 849 joules. To calculate the specific heat, we need to first list the known variables. Q is equal to 849 joules. M is equal to 95.4 grams. C is our unknown. And delta T is 23 degrees Celsius. I took my final temperature, 48 degrees Celsius, and subtracted it from 25 to get 23. Determine the product by plugging them into my formula. Q is equal to mc delta T. 849 is equal to 95.4 grams times C times 23. Solve for C. I'm going to divide by the products here, 95.4 times 23. So C turns out to be 0.39 joules per grams degrees Celsius. So another example for you, how many joules of heat are absorbed when 50 grams of water are heated from 30.2 degrees Celsius to 58.6 degrees Celsius? Here are your unknowns. Here's all your listed. Now I want you in your notes to solve the equation. I'll go over it tomorrow. There's another problem I want you to try. I'll give you the answer when we go over this in class. And I want you to check your understanding. So now do the whole process, list out all your unknowns, solve for the product, and I'll go over this in class. All right, so now you are able to calculate heat, specific heat, and the mass and change in temperature of a reaction. Use your reference tables to determine the correct heat formula used and find the physical constants for water.